Hello, the internet. I'm coming to you on YouTube. The goal of this video is to explain to you the climate of planet Earth as well as the future climate, aka global warming. Full disclosure as to my expertise on the subject, I am an astrophysicist, so I understand climate very well. And then once I talk about that, I'm going to try to do it in as short of time frame as possible. And I'm try to use language that everybody can understand because I teach non-science majors in my college classrooms. Then I'll talk about what the solutions to global warming would actually need to be. So climate comes in two parts. The first part is rainfall. We're going to ignore that. That would take much more than 5 or 10 minutes to talk about. I could do probably 3 whole videos on that, each hour long. You don't want to watch those. And temperature. So we're going to focus on temperature. By the way, the Christmas tree in the background has no special meaning. I thought it just really cool. So we could get a picture before we take it down for the year. Temperature of any object of a given material depends on one thing and one thing only: energy. Just like the strength of a business depends on money, the strength of your temperature depends on energy. If you have more energy, you have a higher temperature. If you have less energy, you have a lower temperature. If you collect more energy than you emit, your temperatures go up. If you emit more energy than you collect, your temperatures go down. It's as simple as that. So when we want to look at the Earth and look at what affects the Earth, we just have to look at what affects the energy. And of course, the most important one is the sun, by far. In fact, we have an 11-year solar cycle that changes the sun's brightness by 0.1%, which is very small. But if you look at the climate history of the last 100 years, it does go kind of up. But on top of that, there's about an 11-year sine wave that corresponds to about 1 or 2/10 of a degree Celsius. It's not a huge change, but 0.1% is not a huge change in the brightness of the sun. So let's prove that energy, in this case the sun, can actually influence temperature. Well, let's look at one single day. What's the highest temperature of the day? It's usually in the afternoon. But when do we get the most sunlight? That's at noon, when the sun's at the highest. So what gives? Well, when the sun's at the highest, obviously we receive more energy than we emit, but that doesn't magically stop happening. As temperatures go up, you emit more heat. As the sun gets lower in the sky, we get less heat from the sun. At some point in the late afternoon, those two numbers cross, and that's the peak of the temperature. After that, temperatures go down because we now emit more energy than we receive from the sun. Similarly, the hottest time of the year is not June when we get the most sunlight, but August. Because again, that's the point at which the amount of sunlight we get from the sun on a given day and the amount of energy that the Earth emits in a given day equalize. That's called equilibrium. So energy determines temperature. So what are the other 3 processes that determine energy for the Earth? The second one is reflectivity. The more light you reflect, the lower your temperatures because the less energy that you have. The third one, and these are not in order of importance, is the circulation patterns of mostly of the ocean, but also the atmosphere. These bring energy from the equator, which has more energy, up to the poles. And it decreases the energy that the equator has, which would decrease the temperature the equator would have otherwise by a very slight amount, but it increases the temperature of the poles by a lot. So the more circulation that you have, energy you have, the higher the average temperature of the Earth. And then the fourth one is the one I want to spend the most time talking about, and that's the atmosphere, aka the greenhouse effect. Now, there are certain gases in our atmosphere that allow the optical light from the sun to pass through our atmosphere. Our Earth absorbs this heat and then it emits its own heat, but it emits the heat in the infrared. There are gases in our atmosphere that absorb the infrared energy from the Earth. These are called greenhouse gases. Water vapor is the most abundant, but carbon dioxide is the one we talk about the most because it's the one that we humans can actually control. So the atmosphere absorbs this heat, does not trap it. I hate the word trapped. The trapped gives you completely the wrong picture. Do not use the word trapped. It absorbs that heat and then it emits the heat, its own heat. Some of this heat goes up into space. Some heat comes back to the Earth. I want to see it's 50-50, be simplistic. It's actually 40 up and 60 down. There are complications with multiple layers. I won't get into that. And so the reality is now the Earth has 2 sources of energy, the sun and the atmosphere. The atmosphere heats the Earth by about 60 degrees Fahrenheit, meaning if you got rid of all the greenhouse gases, the Earth would cool by 60 degrees and be very, very frozen. So it's good in moderation. But as we increase the carbon dioxide we have in our atmosphere, this increases the amount of heat that the atmosphere could absorb, which means it increases the amount of heat that the atmosphere emits. So basically what's going on is our atmosphere acts like a heat lamp powered by the Earth's own heat. And as we increase the carbon dioxide, this heat lamp is getting brighter. The only possible result of this is that the Earth has to get warmer. It's not a matter if, it's a matter of how much, how soon, and what are the side effects. And scientists do not agree on the how much. That's a big thing that the scientists do not agree on. Right now, the energy imbalance, the amount of energy the Earth gets versus emits, is approximately 7/10 of a watt per square meter, which doesn't sound like a lot, but it can heat a half mile of ocean, about 1 degree Celsius in about 100 years, and that seems to be the rate at which warming is currently going. I don't really buy and believe into the 5 to 10 degree Celsius per century models. I think they're insane. The numbers just don't go that direction. All right, so that's global warming in 6 minutes. Not that complicated. Now, you can go down the rabbit hole and get really complicated with side effects, such as feedback effects. It can get quite complicated, but that's the basics of climate and of global warming. Now, as promised, what do I think the solution to global warming is? That's going to be the rest of this video. It's not coming from government. If you're expecting government to solve the problem, forget it. Government cannot solve the problem. It is physically impossible for them to solve the problem. It is not a problem that governments can have effect on. I mean, they can minimize it, but they cannot fix it. It's like a team that's losing by 50 points a game. Government can come in and change the rules of the game and make it so that team only loses by 30 points per game. Sorry, that team's still losing. Fire the coach, fire the GM, and fire the owner. Sometimes the owner's the problem. So if not government, who? This is a problem that is not solved by government. It is solved by engineers, entrepreneurs, scientists, etc., business people. That's who are going to fix this problem, not government. In fact, I would argue that this problem is not an environmental issue. The environment is actually the side effect of the issue and not the issue itself. The issue is that fossil fuels are the cheapest, most plentiful, abundant, and easy to get fuel source for the human race. And so that's what we use. If you want to switch, you've got to make another fuel available and cheaper. If you can make solar panel arrays for a house that could do all your energy for your house and the battery backup for when the sun's not out at night, and you can get that all done for $5,000, maybe $10,000, everyone who's paying $2, $3, $4, and in California more on energy costs per year, all switch. Energy revolution overnight in a decade's time, and oil's still used for plastics, but nowhere near the speed at which it's currently being used. And we could actually go to being carbon neutral, meaning that the amount of carbon that gets drawn out of the environment by natural processes, which is mostly the ocean, would equal to what we human beings pump into the atmosphere, so that the amount of carbon dioxide in the atmosphere stays constant. And we've got about 40 to 50 years to do that before we change our environment in a way that we can't unchange it. I'm not going to say that's a good thing or a bad thing. That would be a completely another video, which would involve Panama 3 million years ago. I'm not getting into that in this video. If you want to see that video, talk to me in the comments, and if I get enough people to say, hey, I want to see that video, I'll do it, but otherwise not so much. So a reminder, I am an astrophysicist. I do not do any research in astronomy or in climate. I just teach full-time at a college, but I am an astrophysicist, so I do understand climates not just of Earth, but of other planets. So that's my credentials. So what is the solution? Well, we need to help the entrepreneurs. How do we do that? My proposal would be that we start an investment fund, similar to an ETF that everybody could invest in. And also in their retirement accounts. They can invest in their retirement accounts as well, just like any ETF. And what this ETF would do is that every 3 to 6 months, you'd have a panel of business people that would call for proposals from businesses that are going to sell part of the company, say 49%, and they need funding to, make their company work. And so you would base that similar to how NSF works for research grant money, except for that they're actually selling the company and that it's not a free research grant. And so what this does is it gives average people like me a way to invest in startup companies that I would absolutely not get otherwise. It gives businesses an easy access to money, and I would make it so that if they get denied, then they get a letter stating why they were denied and helpful tips of how to make their business model better. So they win even when they lose. And of course, businesses, like I said, they win. And the best thing is the taxpayers win, because the cost of this would be paid completely by the investors, just like any ETF. The cost of the American taxpayer would be zero, nada. Yeah, I'd like to see anyone on either side of the aisle come up with an idea that costs the taxpayers zero and solves a global problem. They don't know how to do that. They just simply don't. That's why you can't count on the government to solve the problem. Not in this case. And so that's my proposal. And I would do one for solar, I would do one for just green energy, one for technology in general, and just one general company, one so you're not picking winners and losers, because some people won't want to invest in energy or anything like that, just random companies. And so I think it'd be good just to have one just for any company that any company startup could apply for. So that's climate, global warming, and the solution. If you have any comments, have any ideas, have any thoughts, feel free to add them in the comments. Otherwise, I'll see you in the next video. Bye, YouTube, and all the cats that walk across the keyboards and watch my videos, which is like 90%.